Good morning, students. Let's start with chapter atmosphere. In this video, I am going to explain you topic wind. So before going to start this topic wind, I want to explain you two important terms. So let's start with the two important terms. The very first one is isobar. What is isobar? Imaginary line joining the places of same pressure condition. That is isobar. Iso word stands for same, bar means pressure. If I'll draw a rough sketch, so this is southern India, and in this way we used to show the isobar. These are the imaginary line join the places of same pressure condition. Next term that is very important, that is pressure gradient. Now what is pressure gradient? Pressure gradient means that is difference in pressure between two places, that is called pressure gradient. Just imagine there are two places, place A and place B. So difference in pressure between these two places is known as pressure gradient. So now after these two terms, let's start with the introduction of this topic which we have to start, that is wind. What is wind? Everybody know what is wind. Blowing air is known as wind. And when air blow in a horizontal direction relative to the earth surface is known as wind. How air current is different from wind? Now we have to learn the next term, what is air current. When the land gets heated up due to direct sun rays, so the air that comes in the contact of this landmass, so definitely air also become warm up, and warm air is light. As a result, the warm air rises upward. So when the air blow in a vertical direction relative to the earth's surface is known as air current. So these are the two important definitions, wind and air current. Now the next topic, that is factors affecting the speed and direction of wind. Now what are the factors? The very first factor is Coriolis force. Everybody know what is Coriolis force? As we know that earth rotate west to east, speed of rotation is maximum near equator. So due to the rotation of the earth, Coriolis force will be produced and wind gets deflected from their original position. Wind always deflect right in the northern hemisphere and left in the southern hemisphere. This is called Farrell's law. Farrell's law states that due to the rotation of the earth, Coriolis force will be produced, and due to this force, wind gets deflected right in the northern hemisphere and left in the southern hemisphere. So in this way, Coriolis force affects the direction of the wind. Now next we will discuss the another factor that is very important, pressure gradient. I have told you in the beginning also the two important terms, What is the meaning of pressure gradient and what is isobar? Both terms will involve here. As we know, what is pressure gradient? Difference in pressure between two places is known as pressure gradient. Isobar, I have told you. Now, if I'll repeat again, isobar means the imaginary line join the places of same pressure. Now, how pressure gradient affect the speed of the wind? Now, pressure gradient that will be represented in two ways, that is steep pressure gradient and gentle pressure gradient. Steep pressure gradient will be represented by closely packed isobar, whereas gentle pressure gradient represented with widely apart isobar. Now, steeper the pressure gradient, the speed of the wind will be high. And gentle the pressure gradient, the speed of the wind will be low. So in this way, pressure gradient affect the speed of the wind. Now, another important point that we have to learn, when the wind or air blow near the earth's surface, if the air blow near the earth's surface, that air that do not blow freely, because there are so many irregularities, unevenness will be found or will come in the path of the wind. Irregularities in terms of if the mountains, hills or plateaus come in the path of the wind, then this unevenness, irregularities causes friction, and due to friction the speed of the wind will be slow. So these are the factors. Now we have to start the next part, that is types of wind. There are three types of wind. One is permanent wind. Next is seasonal wind. Third one is local wind. Fourth one is variable wind. So in this video, we'll discuss permanent wind in detail. And in next video, I'm going to explain all these winds to you. Now let's start with the permanent wind. Now what we have to learn here, the very first we have to learn meaning of permanent wind. What is permanent wind? A wind blow throughout the year is known as permanent wind. Next we have to learn about other names. What are the other names of permanent wind? Permanent wind is also called prevailing wind or planetary wind. And last we have to learn about the subtypes of permanent wind. Now what are these subtypes? The very first one we have to learn trade wind. Second we have to learn about westerlies. And third we have to learn about polar easterlies. Again I am repeating meaning. Permanent winds are those winds which blow throughout the year. Other names are prevailing wind or planetary wind. Subtypes of permanent wind are trade winds, then westerlies, and the last one is polar easterlies. So next we have to learn about subtypes. There are three types of permanent wind: trade wind, westerlies, polar easterlies. So we will learn this with the help of the diagram. Now first we have to take a recap of the pressure belts we have discussed in previous video. Now this is 0° equator. As we know, 5° north to 5° south. What we call this pressure belt? Equatorial low pressure belt. Next we have the pressure belt in both the hemisphere, that is 30° north to 35° north, 30° south to 35° south in both the hemisphere. What we call this? Subtropical high pressure belt. Same here also, subtropical high pressure belt. Then next, here also I will write subtropical high pressure belt. Next is 60° to 65° north. You will find some variation in different books about degrees, but roughly we can say this 30° to 35°, or we can say around 30°, around 60°. Okay, so here we can say in both the hemisphere the next pressure belt is 60° to 65° south, that is subpolar low pressure belt. This is also subpolar low pressure belt. And the last is, that is 75° north to 90° north. Here also 75° to 90° south. This is called in both hemisphere polar high pressure belt. This is also polar high pressure belt. So these are the different pressure belts that I have explained you in the previous video. Now why these pressure belts are important here? Because with the help of these pressure belts we will discuss, or we will mark different types of permanent wind. As we know, wind always blow from high pressure to low pressure. Here low pressure, high pressure, low pressure, high pressure. So we have three types of permanent wind. First is the trade wind. So first we will learn about some important points about trade wind. Trade word derived from Latin term trado, which means constant direction, and from German term trade, which means track. So this is the introduction. Trade is a type of a permanent wind. Trade wind blow in tropical region. So trade wind always blow from subtropical high pressure belt to equatorial low pressure belt in both the hemisphere. Subtropical high pressure belt to equatorial low pressure belt. And the wind, trade wind that blow in northern hemisphere, means in this part, this is called northeast trade wind, and in southern hemisphere these trade winds are called southeast trade wind. Northeast and southeast trade wind meet at equator, and this part is called ITCZ, intertropical convergence zone, where two winds meet, northeast and southeast trade wind. These winds are comparatively dry. These winds blow from low temperature to warm temperature. as if we'll go, you know, higher latitude, if we will move toward higher latitude, definitely the temperature will be low. Or near equator, everybody know temperature is warm. So these trade winds blow from subtropical high pressure belt to equatorial low pressure belt, means from cooler areas to the warmer areas. These winds are comparatively dry and the speed of these wind is less. The velocity of these wind is less. So these winds blow in the latitude region, we can say 30 degree north to 30 degree south, or we can say that 30 degree north to 30 degree south in tropical region, we can say. So this is about the trade wind. Next we have the next permanent wind is westerlies. Westerly wind blow from 35 degree to 65 degree north and south, and these winds blow from warmer areas to cooler areas. So in northern hemisphere, the winds blow in this way. The direction I have marked here, in this way, westerly winds blow from subtropical high pressure belt to subpolar low pressure belt in northern hemisphere. Here also, these westerlies blow from subtropical high pressure belt to subpolar low pressure belt. Now, if we will compare the speed of these winds, westerlies in northern hemisphere and westerlies in the southern hemisphere, the speed of westerlies which blow in northern hemisphere is less, and the speed of westerlies blow in southern hemisphere is high. Now what is the reason behind that? The reason is the winds westerlies which blow in northern hemisphere, here in northern hemisphere the concentration of land is more. So there is more land mass in northern hemisphere. As I have told you in the beginning, if more irregularities will be there and unevenness of land masses will be there, lots of mountain, plateaus, plains come in the path of the wind, so the speed of wind will be less, because unevenness and irregularities causes friction. So here the speed of the westerlies in northern hemisphere is less, and in southern hemisphere the speed of westerly is more, that is high. Why? Because the concentration of land is less in the southern hemisphere, so less friction will be there. Concentration of water is more in southern hemisphere, so we can say the speed of westerly is more in the southern hemisphere, and we have given different name to westerlies at different latitude. As I have told you, westerlies blow from 35 degree to 65 degree in both the hemisphere. So at 40 degree latitude, what we call these westerlies, that is roaring 40s. And what we call at 50 degree latitude, what we call the westerlies which blow in southern hemisphere, that is furious 50s. Roaring 40s, furious 50s, and what we call at 60 degree latitude, 60 degree south, 50 degree south, 40 degree south. So what we call these westerlies at 60 degree, screaming 60s. So it's all that speed of the westerlies will be very high in southern hemisphere. One more point is there. Westerlies blow in the opposite direction if we compare with trade wind. Trade wind blow in this direction and westerly blow in opposite direction in both the hemisphere. So in this way we can say westerlies are also called anti-trade winds. Anti means opposite. So these winds are blowing in opposite direction. And now the last type of permanent wind is polar easterlies. Polar easterlies blow from subpolar high pressure belt to subpolar low pressure belt. in both the hemispheres. Polar high pressure belt to subpolar low pressure belt. And these winds are comparatively cooler than the other winds like westerlies and trade wind. So this is about the trade. These are the three types of the permanent wind. So we have discussed till permanent wind. In the next video, we will discuss about seasonal wind, local wind and variable wind. Thank you, students.